More episodes like the one now live in. The coronavirus has shown us that every single change matters, and it's our personal responsibility to act according to this challenge, to face this health problem, but also to deal with the bigger challenges we have been detaining for so long, such as climate change. And if the experts in the field say that water is going to be the next big problem of our world, the Bluebloqs Project represents one great opportunity to contribute to mitigate and reduce coming events. After the Second World War, we have lived a massive migration from rural to urban that in most of the cases was not planned nor even resolved, resulting in cities designed to be eroded, prioritizing the communication ways over a more human scale and natural way. Now, this development is getting us serious problems like floods, extreme heat islands, desertification, and the list goes on. This is why technologies like Bluebloqs, which center our streets as the channels to collect rainstorm water for later being stored, purified, infiltrated, and reused, has never been so necessary. And that's exactly why we must contribute by spreading this type of technologies to be implemented in our cities. We really thank Karina Peña and the Massive Field Factor team for bringing us the chance to participate in this project and to contribute to the dissemination and implementation of their technologies across Europe. And now I let you with Karina, and that will tell us more about the Bluebloqs circular water system. Thank you all for being here, and Karina, it's time for you now.
Yes, let me see how I share my screen. Well, first of all, thanks everyone for joining us today. Thank you, Francesca, for the introduction. I will see how I am able to present my screen. Sorry. Yes. I guess you're. Oh, why? Are you able to see my screen now?
Yes.
Yes.
Wait, I lost my navigator. I started somewhere in there. I guess you have it now.
Yes.
Is that right?
Yes.
Okay. Now, well, first of all, thanks for the introduction again, Francesca, and you all for joining us today. I will indeed explain what it is about the Bluebloqs circular water systems. And first of all, introduce myself, maybe for the ones who don't know me yet. I'm Karina Peña, and I'm co-founder of Field Factors. And I am a landscape architect by training and passionate with water. I'd like to first start by inviting you to take a look to our cities, to the way how we build cities, or let's say to our current urban water model. So when we think about cities, and when the way how we have been building cities since the 19th century has been, of course, accompanied with kilometers of piping work to collect, distribute, and discharge water, first from the source to the users, and then most commonly to the final destination, normally the treatment plant or the sea. But with the current challenges our cities are facing, or we are facing, with more people living in the cities, mean that this paved surface is being increasing, but also that the more people needing water or demanding larger volumes of water. So it means that we will require larger sewers and more drinking water to meet that or supply the need of our thirsty urban population. It means, of course, that it also makes obvious that this current model has reached its limits, right? If we continue doing this way. So probably the solution could be a more circular, flexible, and decentralized model that helps us gradually upgrade our aging urban infrastructure to meet not only to cope with larger and more intense rain events, but also to guarantee the availability of fresh water for the urban population and for the future generations. How it can be implemented, we see it feasible through small scale solutions or small scale infrastructure. Our city's compact is busy enough. So if we upgrading or changing at once the whole system, it's not feasible, right? But through small interventions, one project at a time, every time we change or renovate a new neighborhood or new street, or are faced with a new urban development, is a new opportunity to change the system, or to do it differently, right? So what we propose is, or what we see, or we envision these nature-based solutions as an opportunity to keep rainwater in the neighborhood, and in that way create a local water source for the local water demand, to supply the local water demand, which can be implemented every 500 meters. In this way, really driving the transition towards climate resilient cities. And that's what we do at Field Factors. Since 2016, we have been developing the Bluebloqs technology to enable rainwater storage and reuse in urban areas. And what is that? So what we see in this video is the 5 steps or the 5 functions we integrate through our technology to enable this rainwater storage and reuse. What we see is that we collect rainwater runoff from paved surfaces, which could be roofs or just pavement streets. We retain, normally this water, if you collect stormwater, you normally need a retention solution to temporarily store that water, which can be done in different ways. Could be an underground retention system, but could also be a pond. Of course, this water, rainwater runoff is not as clean as we sometimes think. It is, of course, polluted once it gets in contact with the urban activities and the urban context. We treat that water with, sorry, it's not so plain enough. We treat that water with a biofilter, which is a natural treatment system which can be integrated in the urban scene or urban landscape as a green feature. And where we find a space to store these large volumes of water is in the underground, using the subsoil to store the water, where it can be stored for large period of time, or let's say for longer term, to be then recovered for different uses. So in this way, really having water available when we need it in the dry periods. So you might be thinking, how can this be applied? So first, I think the first thing we need to think of is when designing with water when designing with water, we really need to think in other ways, or to change the approach, how we build cities and how we design cities. So instead of already thinking, I need to discharge my water, or consider a local retention solution, we encourage you just to take a look at your water sources, whether it's or rainwater sources we find in the urban landscape that you normally need to manage. You see it's a rainwater runoff or phreatic groundwater, as normally happens in the Netherlands, or surface water. So how can you use or manage the surpluses of these sources and store it for when you need it in the dry periods? So let's take a look, of course, on designing with these different water sources, or managing these different sources to apply our solution, or the Bluebloqs circular water system. It allows, so as it is flexible and modular, it can be implemented in different ways, or designed. The technical solution will be different for the specific project. So storing rainwater runoff, of course, normally you need to store large volumes of water. That's the problem we are facing nowadays in cities. And we do that with a minimal footprint to prevent, of course, sewer overflow. That's what's most needed. So normally you can, if you have a separated sewer, you can do it in a separated sewer, but you can also think, and from there probably retain temporarily your water, then treat it, and then bring it to the through infiltration wells to the underground for later recovery. But you could also think on just using the streets as a way to distribute your water to the temporary treatment, retention, sorry. In the ways that the same happens when it can also be applied to create a more stable groundwater level, and in that way also reduce the land subsidence. We also in the Netherlands is and other cities, of course in the world, especially coastal cities, is a common problem. So in that way, you can also use the technology to drain when the groundwater level is high, you bring that water to the underground and put it back when you need it. So because we need to stabilize the level of water in this type of applications. Or for instance, when you have using the system to increase your current surface water system, to increase the capacity of that. For instance, if you have ponds, or you could use the technology to bring that water into the underground and regulate the water levels so that the current systems of surface elements can provide more retention capacity for next events. But also in a way that you could preserve the water quality by recirculating the water, the surface of just urban water elements in the public space. And in terms of use, you might think, but is it drinking water? It's not drinking water, but have you ever thought of the multiple applications of water we have for all urban functions, which don't require actually drinking water quality? For instance, think on what I just mentioned, stabilizing the groundwater level, but also processed water for manufacturing or industrial processes, irrigation of urban green, sport fields, flushing your toilets, but also recreation and provide cooling in the hot days. So, sorry, let's take a look. Where can it be implemented? Actually, the Bluebloqs system is thought to be implemented in every urban development and retrofitting projects. And what we envision it as a enabler of decentralized urban water system in a small scale, which can be implemented one project at a time. So think at the renovation of a new stadium, or a new real estate development project, or the renovation of the public space. Of course, it has limitations, or let's say it's more convenient for projects with specific characteristics. For example, the scale is not for a really small as one house, but we think more on projects from 10,000 square meters from their own. So when that is where you have enough catchment area to be able to store large volumes of water, but where you also have a local demand of more or less 15,000 cubic meters per year. So again, think on a stadium, or toilet flushing, or extinguishing water, and so on. And the system footprint, as I mentioned earlier, the main barrier to implement nature-based solutions in cities is that we normally hear we don't have a space. The city is busy now. So that's why it is thought, especially for highly dense areas where we don't really find the space, just to have a small, still green systems, which is very compact and effective. So the footprint is from 30 square meters to 100, depending on the project scale, of course. And why do we do this? So at the end, we are all looking at or facing the need and the challenge in our cities to create more, to make our cities greener, but also cool and climate resilient. But the great benefits of changing towards more circular local water management is that we, of course, lower our drinking water use. So we use drinking water for really potable human consumption, or for when we need drinking water quality. But in that way, we also reduce the pressure on the natural water resources. We prevent sewer overflow, which is a common problem in all our built existing cities. We lower cost of the sewer replacement as well, because in this way, instead of now enlarging the piping network to create kilometers of extra discharge capacity, we can do it locally by just going vertical and using the underground or the subsoil. But we also improve the spatial quality by adding green and enhancing the biodiversity. And of course, after all, it's a way to restore the natural water cycle in the cities, which has been, water cannot infiltrate anymore. So we just contribute to adding water to our depleted groundwater resources. So we started, where all this started was in 2016, with just an idea, and bold and ambitious idea of a young group of people thinking that we could change the world. So at the end, we came to Delft in 2016, founded our company, and we had the opportunity in 2017 to implement and test our ideas to prove feasibility. We did that in a test site here in Delft, which is called the Green Village. There we had was our playground to test solutions, to fail as well and improve. Once we could prove it worked, that the solution works, we were able to implement in a first pilot in Sparta in 2018. So we had also, we were lucky enough, let's say, to find a pioneer city or municipality willing to test or manage water in a different way. So we implemented our system in the first pilot in a full scale in Rotterdam in 2018, next to the Sparta Stadium, where the water is being used for the irrigation of football pitches. And from there, of course, after having 2 years ago, having a technology, okay, now we have proved it works, what's next? So we had ambitions of increasing our impact, so creating tangible impact through Europe. So with the main ambition or goal of this Climate Kick project was to demonstrate the feasibility of Bluebloqs technology, not only in the Netherlands, but also prove scalability also across Europe. So to test it in other climate conditions, but also in other institutional settings with other water needs. And at the end, we believe this is a way how we can really create tangible impact to create green and resilient cities. We will see the results what we have achieved these 2 years in the next presentations. Thank you. Are there any questions? I'm open to that. Adam, who is managing next?
Adam, are you there?
Okay, maybe I can also answer some questions in the meantime.
Boris says he has a question.
Yeah.
Okay. Yeah, I cannot unmute myself. So thanks for doing that. Thanks, Carina. I have one question that puzzles me a bit for a time. So there are various types of water that you can store in the underground.
Yeah.
But what's the advantage of storing surface water particularly? Because I can understand the logic of rainwater and phreatic groundwater, but surface water seems a quite controlled water body. So what's the concept there? I missed that a bit.
Actually, two things, I would say. In the Netherlands, what we used to do is just to pump the water away from the surface water in our whole controlled water system. So in water systems, so in that way, we reduce pumping or pumping water away just to when actually we also need it in the dry periods. In that way, you keep it there. But also, think on other countries where the whole water system is not controlled, as in the Netherlands. You can see the solution in that way as okay, you store water when you have it for the times that you need it. So normally when surface water levels are low, then you can just use the water you have stored in the times of surplus, let's say.
Okay. So it's also to store excess surface water when there's, okay, yeah.
Exactly. And then also think this is more for larger surface elements, but or water elements, but things also on more architectural surface water, or things of ponds or something like that. It's a way also to use it as a buffer. Elements which we have already, we could control the level, so create more retention for when it rains.
Okay, thanks. Yeah, sorry, I have to open the door for my kids. It's lockdown in the Netherlands again, so I have to go to the door. One more. Thanks for your
I hope it was clear.
Yeah, thank you, Carina. I'm sorry I have some technical issues before. And now it's turn. We're going to show you our 4 success stories. First, we have Birgit. One second. Okay. And this one. First, Birgit is going to tell us about the Bluebloqs demo in Belgium. And I will share you a video.
De klimaatverandering is volop bezig. Dit kunnen we niet langer ontkennen. Langere periodes van droogte wisselen zich af met hevige regenbuien. Bluebloqs biedt zowel voor de droogte als hevige regen een oplossing. Het is een compact circulair watersysteem dat gecreëerd werd door Field Factors uit Delft. Het kan gebruikt worden op het openbaar domein. Het systeem vangt het afstromend regenwater van daken, straten of parkings op. Daarna wordt het door een biofilter gezuiverd en ondergronds opgeslagen. Het kan nadien gebruikt worden voor bijvoorbeeld irrigatie van sportvelden, moestuinen, speelwater of voor diepe infiltratie. Het regenwater van daken en straten wordt opgevangen en naar een ondergrondse regenwaterbuffer geleid. Van daaruit wordt het water opgepompt naar de Bluebloqs. De overloop gaat naar de riolering. Het opgepompte water wordt via een bovengronds verdeelsysteem naar de planten geleid. Het is belangrijk dat het water in contact komt met zuurstof om zo nog een betere zuivering te krijgen. Het water loopt daarna door het zandfiltratiebed. Daar wordt het verder gezuiverd. Het gezuiverde water wordt opgevangen in een drainagebuis. Vandaar wordt het afgeleid naar een infiltratiesysteem of naar een buffer. Het water kan in de buffer opgeslagen worden om in tijden van droogte te gebruiken. Het kan dan gebruikt worden voor speelwater, irrigatie of beregening. Dit is de eerste testopstelling van de Bluebloqs in België. Hier testen we wat het effect is van de Bluebloqs op het verwijderingsrendement van onder andere zware metalen en wax. In Nederland zijn er wel al een aantal projecten gebeurd, onder andere in Rotterdam bij het Sparta-stadion. Daar gebruiken ze het water dat gezuiverd is door de Bluebloqs om de voetbalvelden te irrigeren en kunnen zo heel wat drinkwater uitsparen. En ook in Den Haag zijn ze bezig om een demo-opstelling te plaatsen. Daar wordt het water gebruikt voor irrigatie van moestuintjes en ook voor een kinderboerderij. Zoals jullie kunnen zien is de Bluebloqs heel mooi inpasbaar in het straatbeeld. De omranding kan perfect gebruikt worden als zitbank en kan heel esthetisch ingericht worden. Het is een innovatief product en dat vinden wij niet alleen. De Bluebloqs heeft dit jaar de Urban Water Challenge gewonnen. En dat is een wereldwijde competitie voor technologische start-ups die bezig zijn met watergerelateerde zaken. De Bluebloqs zijn een mooie, nieuwe, blauw-groene oplossing om slim om te gaan met water.
Great. So, Birgit, can you share your screen with us?
Yes. Normally you should see it. So, good morning, everyone. I'm Birgitte Bok. I work at the R&D department in Belgium, Aquafin. And as you can see, I will just try to get the next slide. Yes, we built a demo in Aartselaar at our research hall. And maybe just some explanation why we like the Bluebloqs as a solution. The Flemish government just invoked the Blue Deal in Flanders because of the last year's drought. They really want to stimulate solutions for drought, and we think that this really creates a momentum for nature-based solutions such as Bluebloqs to be able to counter the drought problems. So there's definitely a momentum in Flanders for these solutions. And we built the demo in 2019. It's a really small demo actually, just for research purposes. It's only 9 square meters, and it collects the water that runs off from the roof from the research hall. In 2019, we especially looked at the heavy metal removal, and 2020 we were researching the rainwater runoff, the quality and the effect of the Bluebloq on the quality of the rainwater. As I said, we started the project together with Field Factors in 2019, and then we built the Bluebloqs demo in July. From August to December, we had a thesis student from the TU Delft, Pim Versteeg, who is now working for Field Factors, doing some experiments on the Bluebloqs. And then in December, we had a stakeholder workshop as well to show different stakeholders from Flanders how it works, what are the first results, and to ask them as well what they expect from solutions like this. And this year we focused on more organic compounds such as BOD, COD, pH, with weekly sampling, and then monthly sampling of metals and bacteria. But I will get into more detail about that in the next slides. So the sampling in 2019 was done by Pim Versteeg, and he spiked the influent of the Bluebloqs with heavy metals every 3 weeks from August to December. And then he sampled in the influent effluent, but also inside the biofilter to see what the effect of inside the biofilter is on the retention of the metals. This year we focused especially on the influent and effluent for different kind of compounds such as BOD, COD, also suspended solids, NO3, NO2, ammonia, and things like that. And then the metals and bacteria were sampled only once a month. As you can see, the removal efficiency of the heavy metals that were spiked was really high. The first blocks you can see here, this is clearly the startup period where we even saw the running out of metals. But after a startup period, we saw really nice removal rates of copper, lead, cadmium. Only zinc and molybdenum we saw less good results. But we think this was especially because of a bad mixing of the spiked solutions. So because there was very low concentrations going in, we couldn't really see a big removal efficiency. And the same goes for arsenic. The arsenic concentrations were so low that we also couldn't see a lot of removal. It's obvious if you're not putting a lot of concentration in, then you will not get a lot out of it. And then for the pathogen removal, maybe it's interesting to tell you as well that pathogen removal is quite important for us in Flanders, because if you want to do aquifer storage recovery, so deep infiltration of water, then our legislation is really strict on pathogens. So we're not able to infiltrate the water if there's still some pathogens in the water. In the first few months, we saw that there was actually no pathogen removal at all. E. coli was just all over the place. But then when the biofilm starts to form and the biofilter is matured a little, we could see that E. coli was removed better. The same goes for coliforms, but a lot of different contaminations such as Clostridia and Enterococcus were not really removed. There's not a clear trend in the data. So we still have to look a little further into the pathogen removal, or maybe even consider adding an extra step, a UV or something to remove pathogens. For the heavy metals, we saw that very low concentrations were going in. So the influent almost didn't have any metals except for lead. So since the concentrations were almost always below the groundwater restriction levels, it's not that interesting to look at these metal removals since it was so low. And then for the organic compounds, we could see a clear neutralization of pH. So that's very interesting, since it is very important for the metal retention as well. What the pH of rainwater is quite acidic. And BOD, so the organic compounds were clearly removed by the biofilter. Again, we have quite low concentrations. So one of the big conclusions is that the rainwater runoff of the roof in Aartselaar is just actually too clean. So in normal conditions, you wouldn't even have to purify this water since it's so clean. We do see a little bit of nitrogen dioxide. So here we can see that the effluent is definitely lower in nitrogen dioxide as well in nitrates. So in the beginning, in the startup period, again, of the filter, these concentrations were not that good, so the removal rates were not that good, but we can see as it matures that the removal of nitrate is definitely picking up. Now, what are the remaining challenges for us in Belgium and Flanders? Definitely the pathogen removal is something that we have to have a better look at, since the ASR is not possible regarding to this water quality. We have very strict legislation regarding to the pathogens. We also lack values regarding to recycled water use. For example, plain water, we don't have very clear legislation about that. So mostly now people use drinking water or drinking water quality normation, and obviously that's very strict. So that's something that we should look at with the governments. And also a very clear operational guidelines are very important for us. If you want to stimulate municipalities to install Bluebloqs, then it has to be really clear how they have to operate them, how it will work to have a guaranteed water quality. What's next for us? Since the runoff water of the roof is so unpolluted, we will look for a new location to install the Bluebloqs. So we can keep on measuring. Definitely polyaromatic hydrocarbons is something that we want to have a look at. Also mineral oils, because we can see that runoff water of streets contains these components sometimes. We will follow up on the studies that are being done by TU Delft and Field Factors, of course. And we will keep on looking at legislation about ASR, because we think that's a very, very important aspect of Bluebloqs, or a very important plus point. If you can store it in the deep underground, you can, you do not need that much space, and that's something that in Flanders is quite critical. So I think I'm at the end of my presentation. If you want any more information, or if you have questions, then you can ask them now or send me an email later. So then I thank you. I'll try to stop sharing. Whoops. Then I can see the questions, if there's any questions.
Thank you, Birgit. Yes, there are two questions. The first one is from Alexander. Alexander, do you want to do your questions to Birgit?
I think we have to unmute him then.
Good afternoon.
Yes.
Hello.
Hello.
Thanks for your presentation, but my question was to Katrina, the former presentation, but maybe you can answer them also. Maybe not too difficult. My question is about the time the water stays in the biofilter to have the cleaning do his work, of her work, before infiltrating to the lower buffer. Can you tell something about that, please?
Yeah, I think I can answer, although my colleagues will... I am listening to myself. Thank you for your question, Alexander. I will try to answer a little bit. I'm listening myself, though. Although my colleagues will touch on this in next presentations. The quickest way, the short answer is, actually it's not that water doesn't really stay in the biofilter. It runs through the or it flows through the biofilter, which is dimensioned, of course, to guarantee a specific retention time, as in contact time of the water with the media, to guarantee a specific quality. We dimension depending on the quality of the influent and the targets we need to achieve. So in terms of how polluted is the water and what are the targets based on legislation to be able to infiltrate. That said, we have two parameters to dimension the system, which is first the hydraulic parameters in terms of the flow rate we need to achieve. So how much water, how fast water needs to go. And based on that, to guarantee the water quality, we dimension the system, which can be, let's say, I don't know, 5 cubic meters per hour, 10 cubic meters per hour. And then in that way, the biofilter is dimensioned. I hope I could answer your questions. Otherwise, I think Joshua will can tell you more in the presentation, in his presentation.
Thank you, Katrina.
You're welcome.
Thank you. We have another question from Michael Bates. Michael, do you?
Hi, I would just like to know about any maintenance requirements of the system. Does it require any ongoing maintenance?
I guess that's also for me. My colleagues are also here and can say more. Of course, as every system, it needs to be maintained. Things depending on the system components you have. So if you use a retention unit before the retention tank before the biofilter, of course, you need to check, let's say, per year, twice a year, something like that, the accumulation of sediment and clean that up. The biofilter itself is not much of maintenance. more, of course, the plant is the main maintenance, and the infiltration wells. You need the field. Something good to mention. I don't know. I don't think I forgot to elaborate on that. But the system is completely is operated remotely, which means it's completely automated. So we through monitoring, we can identify needs for operations, or if it is any sign of clogging or something like that. Of course, the infiltration wells, of course, as every infiltration wells need to be also cleaned. So, but we have clear maintenance guidelines for the systems.
Thank you.
You're welcome.
Yeah, Birgit, Bill Rick Cook, thanks for your presentation, and ask about how do you see a Blue Deal project can help you to overcome the boundaries on legislation?
Mm-hmm. Well, the Bluebloqs, the Blue Deal, sorry, the Blue Deal project is making a lot of people aware that drought is a problem. That's definitely a first step, but also since they are focusing now a lot on the reuse of water and also infiltration of water, it brings up a lot of holes in the legislation and a lot of problems that we still face to do reuse, because now they really want to stimulate and urge people to reuse water, to infiltrate water, and now it brings up the problems. Before there was not so much attention for this for the reuse, and it stayed a little bit under the radar, but because of the Minister Zuhaldimir now really focusing on it, we have a big platform now to bring up these problems and to make it to just speak about it, and to really get the parliament as well and ministers as well acknowledge that there's still some emptiness in the legislation. So I think projects like this can really show that there's a lot of potential, and that that there's a lot of research being done as well. The example of the Netherlands, for example, if you can show that it works in the Netherlands, that they don't have any problems with the bacterial contamination in the deep soil, then it can help us to bring across our the good examples and convince the environmental agencies as well that it is possible without risk.
Thank you, Bridget. Okay, now it's my turn to show you the demo of Kaleido here in Spain.
Pero hemos decidido probar esta tecnología porque de alguna manera la historia de las ciudades es la historia de la impermeabilización del territorio. Y esta tecnología lo que pretende es volver a permeabilizar parte del espacio público de las ciudades, hacer drenante parte de los pavimentos de las ciudades como una mejora de gestión del agua, de la gestión del agua y también de la calidad del medio ambiente urbano. La idea del ayuntamiento es hacer extensiva esta tecnología a toda la ciudad, no solo a algunos ámbitos experimentales como hasta ahora, porque creemos que esto es bueno para la ciudad, es uno de los nuevos criterios de sostenibilidad, y a partir de ahora todos los proyectos que se redacten y que se ejecuten de remodelación de espacios públicos o de creación de nuevos espacios públicos incorporarán esta técnica, haciendo que parte de esos suelos sean permeables y de esta manera hacer más racional la gestión del agua.
Well, sorry for the subtitles. We have problems with this. But as you see on the video, the Calado Park urbanization is an iconic place of the city in Madrid. And this green area is surrounded by the 5 skyscrapers of the city. And the Bluebloqs system will be located on the confines of the architectural pond at the center of the park. The stormwater runoff will be collected through the park's rainwater collection systems and treated using the Bluebloqs biofilter to later be used to maintain the water level of the architectural pond. The complexity of the project is the weather conditions in Madrid, because they are different than the other 2 demos in Netherlands and also in Belgium, as it's a semi-arid climate with an average annual temperature of 13.7 Celsius degrees and an annual precipitation of around 450 millimeters. And another thing is another innovative aspect is the application of the system to treat the rainwater for direct use without the surface storage step. And well, as I said, the characteristic is to try this on this new climate, and also to collaborate along the municipality regarding the water quality for the water quality removal from stormwater, as in Madrid or in Spain we have not a specific legislation on this regard. This is this is the aspect of the biofilter, or all the steps that the Bluebloqs system will have. And the first step is the infiltration, the filtrations and sedimentation part. Then we have an aeration and biofiltration part. To then, if necessary, we have a disinfectation part that takes off all the pathogens. And then we have the recirculation of the pond. And well, these are the several parts of the demo that are going to be installed. The construction of the biofilter is underway, because we have long delays due to the COVID-19 problem during this year. And well, all the achievements of this project in Spain is principally the engagement that we have reached with the City Hall of Madrid, and also the agreement with the owners of this iconic place to implement the system inside the park. What are the challenges that we have identified is the lack of proper regulation for the management of rainwater, and also due to regulation, the infiltration and reuse of water directly is complicated and is not allowed right now. But we also identified the lack of benchmark values for use of recycled water in public environments. And also, after the implementation of the biofilter, it's not clear which office is responsible for the management of this kind of technologies. And there are, it needs clarification during the monitoring period of the system. And now, do you have any questions about this this demo? No? Well, I let the turn to Joshua Gallegos, who is going to tell us about the demos in the Netherlands.
Before, sorry, may I just, one short comment, but related to Boris' question before, the project in Kaleido is a very nice example of how the system can be used for to manage surface water. In terms, we will be recirculating there an architectural pond in the park to keep it to good quality. Yes, that to emphasize that.
Thank you, Karina. Well, this is the video of the Hit the Plane in the Netherlands. Let's go.
Hoi, ik ben... En wij leveren circulaire oplossingen om regenwater in steden beter te beheren. We zijn terug op de Green Village met vragen uit de praktijk. Het eerste gebouwde systeem. Wat we hier vooral komen doen is ons biofilter uitvoerig testen. Kijken of we een aantal vervuilingen nog beter kunnen verwijderen. Kijken of we nog wat meer kunnen spelen met de hoeveelheden water. Om op die manier een nog beter, mooier, compacter systeem te kunnen leveren in ons volgende project. Hier op de Green Village vangen we al het water op van het verharde oppervlak. Dat vangen we tijdelijk op in een buffertank. Dan gaat het naar ons biofilter om het te zuiveren. En daarna wordt het opgeslagen, zodat we hier het water kunnen hergebruiken voor de beplanting. Het wordt ook gebruikt in het nieuwe nono-house dat wordt gebouwd voor het groene dak. En om de wc's door te spoelen. Dus geen druppel water gaat op deze manier verloren vanaf de Green Village. Ja, in de zomer van 2020 hebben we deze opstelling gebouwd. In samenwerking met Van Gelder. Die kwamen aanzetten met een enorme kraan waar we heel blij mee waren. Dat werk is heel snel en heel goed gebeurd.
We moeten gewoon met de CO2-ladder mee en groene projecten realiseren. Ja, dat moeten we. Ja, iedereen moet er een steentje aan bijdragen. Dus ja, dat doen wij graag.
Ik ben heel erg blij met hoe het er nu uitziet. Alles is ontzettend goed volgens plan gegaan. We zijn al aan het testen. Laatst was ook de grote opening hier op het Hitteplein. Gelukkig was het 30 graden, zodat iedereen snapt waarom we hier zijn. En ik kijk heel erg uit naar de komende jaren van onderzoek. Meer leren, ons product nog meer verbeteren en hopelijk nieuwe projecten maken.
Great. Joshua, can you share us your screen?
Yeah, I think I can take over now. Can you hear me okay?
Yes.
Great. Good morning, everybody. Yeah, so I'm gonna jump in here. Again, my name is Josh Gallegos. I'm a professional doctorate trainee at the Technical University of Delft, and I'm working with Field Factors on the development of the water treatment capacity of Bluebloqs biofiltration systems. I've been working under the Climate Kick project for about 1.5 years now. And as Adon introduced, I will communicate some information about the systems, demonstrator systems here in the Netherlands. And I think I'm going to be getting back to some of the topics that came up already with Michael and Thomas's questions before. So the first demonstrator that I'm going to highlight here has been mentioned before in the previous presentations. This is located in a neighborhood called Spangen in the city of Rotterdam. And this installation provides water from a collection area of almost 4 hectares of surface, paved surface and roof surface to supply water for turf irrigation inside the football stadium. This is the first full-scale installation of the Bluebloqs technology, and what we refer to the biofilter component as Bluebloqs 1.0. This has been in operation since 2018 and utilizes all 5 steps of the Bluebloqs concept, which I guess are clear by now, but we have collection, retention, treatment, storage, and finally use. And in this case, the use provides about 15,000 cubic meters to the sports field for irrigation. And this is water that is collected during periods of high rain influence and treated and stored in an underground aquifer unit to be used at a later time. Also, on one of the, I think, Birgit's video from Aquafin earlier, you saw a water feature with some children playing, and that's cited here at the Sparta Square as well. So with the Spangen site, under the Climate Kick project this year, TU Delft conducted specifically research on water quality at this location, on the fate of metals, and also fecal indicator bacteria and pathogens within the system. And these are 2 parameter groups that are really relevant to application of reuse, as come up before, and stormwater contaminants that are spoken about a lot, because they frequently do occur in elevated levels in stormwater. So we had 2 master's theses take place, one each on each of these topics, and we learned a lot about how the operation of the system affects performance when it comes to the removal of a wide variety of metals, and also in terms of about 4 different microbes that we were looking at, specifically going into the system and coming out of the system, and actually after the subsurface storage step. So this is quite relevant to the legislative oversight and sort of the permitting process. The metals are on a permit that was granted by the local water board, Delftland, and required to be monitored on a regular basis. The microbes in the Netherlands actually are not a parameter that is looked at on this permit, mostly because aquifer storage is known as a treatment barrier for pathogens, and generally is considered to be quite effective for that. So we are researching how to improve filter performance for pathogens, but that's sort of one way where the climate is a little bit different in terms of legislation between the Dutch and the Belgian context, and indeed also the Spanish context. So another area that we looked at this year was through a partnership with the KU Leuven in Belgium. There's a modeling exercise done by one of the research groups there that used data from the Sparta system. So we have continuous logs monitoring the system through a computer and internet connected device all the time, looking at stocks and flows, or how much water is stored or moving through the system at any given day. So we have about 2 years of record for that. And this group utilized that data to try to come up with quantities of water that can be collected from the street. What does that convert to in terms of going into the ground, in terms of coming out of the ground? And that's going to enable us to forecast more effectively the efficiency of this system especially, but also learn a lot about the proper dimensioning of the retention tank and other filter components as well. So looking at Spangen in depth, I'm referring to the neighborhood, but this can be considered Spangen, Sparta, or Bluebloqs 1.0. We learned a lot about how the water quality is affected by things on this list. So the dimension of the retention tank, and that has to do with how long water spends in that retention tank and how often that tank is emptied. Also, a lot of insight about how water moves through the filter and the effect on that toward water quality. And a last issue that briefly came up before is this topic of backflushing the infiltration wells, which is a normal maintenance procedure that needs to be done to maintain flow in the wells, and what should be done with that backwash water and irrigating the biofilter with water from the ground. The results of these insights, we start to compile in what we call lessons learned, of course, which are really details around operation and how the system is operated to control conditions which will optimize performance when it comes to removal of various contaminants or just different parameters. So there's a need to monitor the system to sort of understand what's going on based on how it's reacting to the influent rainfall, and also to optimize, as one of the participants mentioned earlier, the residence time in the filter. There's no straight answer to most of these questions because the water quality is so variable, and it's variable at a site level, indeed, for each location that you'll install a system. So what we see in certain areas is that certain parameters are quite low, of course, because we're collecting very close to the source. And in other areas, they're higher for different reasons. And in that way, there's a need to be a bit flexible about how you configure the system to achieve certain water quality outcomes. We also learned a bit about the optimal distribution of water onto the filter here, and some insights, lessons about the media that's used in the filter itself, which I'll get back to in some of the coming slides here also. The second installation that I'm going to talk about is the HITAPLINE here. So this is the video that you just saw, and I'm sure I'm not the only one who didn't completely understand the narrative there, but the short of it is that the HITAPLINE is a technology demonstration space. This is the second system that's been installed there. So municipalities and various other visitors will come to look at the HITAPLINE to take a look at upcoming technologies or technologies in development, specifically for climate resilience. The system that we have installed there is a test pilot, and it will be used to test biofilter improvements in support of the full-scale system in Spangen. Some of these improvements will be mentioned on my next slide, but just briefly, the scale is much smaller, of course, here. So we're collecting from about 1,600 meters of paved surface of the Green Village. We have 4 test plots that are all outfitted a little bit differently for testing reasons. And I think in addition to the test function and demonstration function, the water here will also be used to supply a bathroom for toilet flushing at the Green Village as well. And this HITAPLINE it means the heat square, and this is really focusing on demonstrating cooling adaptive technologies or technologies that can contribute to urban cooling. Here on the final piece here, we do not have an infiltration step. We're really demonstrating how the water can be applied to irrigating green space and the other application in the bathroom. So some of the goals here of this pilot is to assess the effects of different media configurations, which we are playing with based on our experience at Spangen. We have designed a new water distribution system, which is sort of a prettier version of the one that went in at Aquafin. You can see it on the right here, but that has a number of different justifications in terms of water quality as well, having to do mostly with water distribution and aeration. We're going to be testing different feed regimes, so how fast you put water into the filters and how long the filter moves through the water moves through the filters there. And we have also made a few additions to the technical components here. Again, this is what we call a living laboratory. It's very near the Field Factors office and on the campus of the Technical University of Delft. So we have ready access to perform research, sampling, very close monitoring and evaluation of what's happening in this system as we make different adjustments that we want to see the results of to this system. The goals of the research here are really focused around manipulating pH and redox conditions, which are highly relevant to treatment of a wide variety of pollutants beyond just metals and pathogens, but looking at dry and wet cycles, soil moisture control, and again, as I mentioned a bit before, balancing feed versus retention, which is sort of a quality versus quantity issue. That's, I guess, it's a pretty clear thing if you think about it a little bit. The longer you keep the water in, the less water you are able to store. Design upgrades I've mentioned a little bit before. So I will move on to the last site here, which is at Chromefleet. So I think we have one more video coming up after my presentation here. The Chromefleet site is located in the city of The Hague, and this is also about a block scale where an urban park has a collection surface of about 8,500 meters. The demand is around 2,000, and the water there will be used to supply urban gardens. So there's a community garden there where vegetables are grown, but also quite a large green area, which you can see of grass, where also a urban farm with livestock animals are kept there. So this will be, again, all 5 steps of the Bluebloqs concept applied, including the subsurface storage. And the novel feature here, besides implementing some of the new components and design changes that we have made since Bluebloqs 1.0 in this first full-scale Bluebloqs 2.0 system, are that this is also the first system which will utilize both surface and rainwater to provide long-term storage for the urban green space maintenance. And again, reiterating what Karina said earlier, their issue with climate change, or you can say just changing weather patterns that we're observing, is that certain parts of the year are seeing more water and certain parts are seeing less. So even in relatively wet environments such as the Netherlands and Belgium, we see bigger peaks in the wet season and lower drops in water availability in the dry season. And of course, everybody I think on the call is probably a bit familiar with public restrictions on water use during dry periods of the year. So we're trying to smooth that curve out a bit. When we take water, when we have it, treat it and put it in the ground and make it available for a time when maybe it's not allowed to take the surface water for various uses anymore. So here we will be testing the Bluebloqs 2.0 improvements. You can see new distribution system is a pretty obvious difference on this one from the previous installations. But we're also going to be continuing some research at TU Delft with a couple of different faculties, my faculty of civil engineering, but also the environmental biotechnology faculty, to look at microbial ecology within the systems. And this is to assess and really optimize the nutrient removal performance as well as natural organic carbon, which is another parameter that's very relevant to the infiltration and let's say the long-term operation of infiltration wells when you're trying to store water in the ground. Again, the design upgrades I went into a little bit already, but we have a different filter media here. We have much elaborated water distribution system that's giving us better spreading and aeration of the water passing from the buffer tank into the biofilter itself. There's also a new well configuration for the infiltration, which allows for longer subsurface storage, which in theory, let's say, or you would assume would give you better pathogen removal there as well. And there is a more sophisticated technical installation here with more sensors, because again, this system, along with the other demos, aside from Spangen, was built more with a research purpose in mind and trying to identify when during operation we see the best results in water treatment performance. So one final piece that's a little bit less technical, but something that's also very interesting to me as a PDN. So I'm sort of, this professional doctorate is sort of half academic and very much applied, is the reality that the function of the systems comes down very much to implementation and operation and human factors. So we have also been developing commissioning protocols to really baseline system performance at the outset, to understand how settings are made in terms of justifications and assumptions that can be compared to how the system performs later over time, and really can provide insight into how we adapt it to improve the performance based on the initial settings. And this is, of course, still a learning process. We've also been developing a user manual to better communicate these sort of details to stakeholders, municipalities, and other project partners, and really monitoring and maintenance procedures, which will elaborate how the basic operations that need to be done to maintain the system and what to look at, let's say. And finally, the operational guidelines is where this ties back to performance, is how do we operate the system and why, and that should all be outlined. And of course, this information is something that we're generating, and we need to communicate eventually in official ways, as I think was referred to also by Brigitte in the earlier presentation. So yeah, going into my reflection here of the work we've done in the past, well, 2 years of the Climate Kick Bluebloqs Circular Water System Demonstrator Project. The first thing I think is pretty obvious to anybody who's worked with public project implementation, but the implementation of our demos was slow. It took a lot of time. It was very ambitious to have 4 running systems within 2 years, novel systems that are not super big, but not tiny in scale. So COVID 2020 being set aside, even the public tendering process and various construction delays and things like this, that gave us a very slow period till we saw these systems implemented. However, that also gave us a lot of time to really zoom in and learn lessons from the system that we have had operating in Spangen, to look at the data from there, to generate a lot of new data from there, and to understand how the way that things have been run in Spangen can be improved, and what has worked and what hasn't worked, and really to be able to translate those lessons into the design of the new system. So that's the other demonstrators that came after, and Aquafin was the first one, and subsequently we designed Hitteplein and Chromefleet after that, which really took a lot of lessons from the work that was done at Sparta and translated that into design and really understanding where we needed to go with the system from there. It's clear that validating treatment performance is still a priority, and that's something that anybody who is thinking about installing something like this is going to be wanting to see hard numbers, hard data about what they can expect from the system and what they'll need to do with the system. And what we have now are demos that I think are well equipped to achieve this, that are outfitted in such a way that we'll be able to collect more data, more information faster than we have up until this point to really shed light on these treatment issues. As I said, I think probably a couple of times already, the operation is critical, and I know this may sound a little bit foreign to when I say that operation. What does that mean? Operation of a green biofilter. Well, logic-controlled biofiltration is still, in fact, a cutting-edge technology space. So there is still not a lot known about this, and there is research in the academic world ongoing that indicates there is tremendous possibilities for optimizing the performance of these filters to provide reliable or more consistent water treatment results. But this is indeed the area that we're working in, and the reason why these demonstrators were set up. So there's still a lot of work to be done there, but definitely we're seeing some very promising things in terms of securing that performance. There is a need to understand how to monitor the systems at this level, which is something that probably operators used to managing conventional systems for municipalities are not experienced with, and will not likely have the resources to spend the kind of time that I'm spending on to do this. But what that leads us to, I guess, is a final point for me, which is that there's a gap between the potential of the system currently and the institutional capacities to operate them optimally. And that doesn't necessarily mean that this is an insurmountable hurdle. Of course it's not, but what needs to be done is the work to validate these design configurations and operational settings, and to produce guidance that can make the system eventually more turnkey or simpler to manage for those who will eventually be managing them. So in this way, we kind of, from the beginning of interest in a project or interest in installing a system, we can communicate a shared understanding about function and requirements all the way through product delivery. And of course, it may seem that operating a biofilter is not a super straightforward task. It's automated. It has online components. It has switches and buttons and things like that. But of course, many of the other routine services that municipalities do today were not super straightforward tasks when they first started either. So that's, I think, where I will leave it. And if anybody has questions, please feel free to come in with those now.
Yeah, thank you, Joshua, for your reflections and for telling us these two demos that are just amazing. I think we just passed to our next with our panel of experts. Even if Thomas have asked something that maybe Julian can ask directly to our experts, right? So I'll leave you with Julian Swinkles and our experts, Manuel de Pastos. Well, I think I have it in here. Okay, Marjan Kranz from BP Delta, Manuel de Passos from the City Hall of Madrid, Wibbel Clem from the City of The Hague, and Luc Rietveld from TU Delft, and Daphne Hermosilla from the UPM. Thank you, everybody, and be welcome.
Yes, thank you, Adam, and thanks to all the success stories I think it's a great pleasure to be here with the current state of climate change. You know, we saw more and more droughts the past years, even front-runner countries like the Netherlands suffering from heat stress. So I think this is really exciting to be here and talking about the future of urban water systems. But maybe more importantly, I think it's time to introduce our experts in our panel. So I'd like to give everyone the opportunity to maybe do a very quick 30 seconds introduction of who they are and their backgrounds before we dive into the questions. So maybe we can just follow the order here on the slide, starting with Marianne.
Yes, good morning. My name is Marianne Grijns. I'm the director of an innovation program called VP Delta. I'm also the director of the Green Village. That's the field lab that you just saw, where Field Factors tested their first version of Bluebloqs and now is testing the second version of Bluebloqs. So we strongly believe in this innovation ecosystems of having startups, field labs, and scientists working together with public parties.
Great. Then next one is Manuel. Are you with us, Manuel?
Sí, bien. ¿Cuál es el enfoque del Ayuntamiento de Madrid hacia este tipo de tecnologías? Pues el Ayuntamiento de Madrid lleva años implementando los sistemas urbanos de drenaje sostenible. Es importante reseñar que la Ordenanza de Gestión y Uso Eficiente del Agua de la Ciudad de Madrid se publicó en el año 2006. En dicha ordenanza se indica que las actuaciones de urbanización, incluidos los proyectos de urbanización de planeamiento, proyectos de urbanización, en los espacios públicos libres y en los proyectos de edificación, se debe incluir un tratamiento de espacios libres de parcela utilizando superficies permeables para minimizar la cuantía de pavimento. También indica una serie de pautas para el control de la erosión y contaminación del agua en construcción y en obras de la vía pública relativos al tema de los arrastres. También en el año 2018 el Ayuntamiento publicó la Guía Básica de Diseño y Sistema de Gestión Sostenible de Aguas Pluviales, Zonas Verdes y otros espacios públicos, en los cuales habla también de los estanques de biorretención, jardines de lluvia, pavimentos permeables. Por otra parte, en la actualidad prácticamente se diseñan todas las zonas verdes con técnicas SUTS y se están realizando evaluaciones para mejorar su eficacia en el diseño, así como en la implantación.
Manuel, can I just ask, are you comfortable with speaking English, or should we have also a translator?
I can translate, Manuel.
Okay.
He just tell us what is the approach of the City Hall of Madrid with this type of technologies.
Okay. So should we have you as a quick translator for yes. Manuel's questions? Okay. Yes. Then we move to Daphne for a short introduction.
Hello, everybody. I'm professor at the Universidad Politécnica de Madrid, Polytechnic University of Madrid, and I have been working for more than 10 years in water treatment and focusing water reuse and water reclamation, because in Spain it's a problem. You know that we are living in a country with a lot of water drunkenness and water scarcity, and we are developing water reclamation projects since 2000, in my case, since 2005. And this is my ground for this project. I think it's very important to reuse rainwater in Europe and in the world in general, and also in Spain. And I think that this project is one important project to develop new possibilities for rainwater use in smart cities.
Thank you, Daphne. And then we have Wiebke from Municipality of The Hague.
Welcome, everybody. My name is Wiebke Klem. I'm a landscape architect and senior planning advisor in the Municipality of The Hague. I work for the Department of Urban Planning and Design. And I am the project leader of a Nature Smart Cities project, from which we financed the urban water buffer in Kronvlietplein. I'm very proud that we managed within 2 years to link this technical innovation to an ongoing restoration process of our public spaces. And I think at the same time it was a challenge, but at the same time we managed to get a lot of insights in advantages and learn from how this can be realized in short term together with the public sector. And I'm very happy to share our insights with you today.
Pleasure to have you. And then our last panelist is the expert Luc Rietveld, professor at TU Delft. Do you want to give a short introduction, Luc?
Okay, yeah, thank you. My name is Luc Rietveld. I'm a professor in drinking water and urban water cycle technology. And yeah, I'm working together with Joshua and Boris on the demo plants and optimizing the treatment facilities mainly.
Luc, maybe a good question to start with for you is if you can share a little bit about the current state of urban water systems and maybe the effect that climate change is having on them, just to have a short foundation of what we're talking about.
Yeah. Maybe I can talk a little bit about the perspective of the Netherlands, and what we see at the moment is that we many times we have floodings during the rainy periods, and now we had two droughts in the last 2 years. So I think more and more, even in the Netherlands, where we think water is always abundant, that we even have periods of time where there is not sufficient water, or where the water becomes brackish, etc. So now there's more and more interest in have resilient solutions for storing rainwater during during rainy periods to overcome the dry periods. And I think that is really interesting. That's why I think these demos will help to see what are also the questions that we have, because if you can think of behind your desk on questions what could be a problem, but if you do your work in the field, then you see really what are problems in terms of technology, but also in terms of organization and governance. But in our field, we are interested mainly in the technical part, and of course, for us, it's then interesting to see how the treatment filter works, the biofilter works, and how we can improve this this system. Because what you want is an effective system that is that has a high loading, so that it can be designed small.
Yes, thanks. Thank you, Luc. Maybe it's also interesting to hear this perspective from Marianne, to hear if are the problems being matched with the technological innovations at the Green Village.
If I look at all these beautiful scientists here, I think I'm very hopeful, because we are very capable of finding technological solutions for the big challenges we are dealing with in climate change. But to accelerate this innovation and making sure it really gets implemented in society, there are a lot of other bottlenecks. And what we see at a field lab like ours, the Green Village, the technology is working fine. We test, we improve, we come with new solutions. But the important part is that people like Wiebke from a municipality, they come here and they see how it works. And also we discuss what kind of legislation or regulation fits with the implementation of new innovation. That's a difficult step. We often think that if it works, it's easy to implement, but there's so many other important factors involved. Also, what does the general public, what does the society think about it? But also for the companies, like Field Factors. Kieran is the business developer of Field Factors. I think he also has a difficult task of making a good working business model for his innovation. So the innovation itself works well, but how to make sure they're also going to make a sustainable business out of it. So there's so many different elements of bringing innovation to upscaling. And I think that's why we need all of us here, not only scientists, but also especially the public partners and the general public, And that's my important message. If you work on innovation, you must have this broader view and look at all the stakeholders involved.
Yeah, correct. I think it's so looking at the municipalities, they're really the demand owners in this sense. They have to manage the heat stress and the drought stress and the water systems in the cities. So it's very exciting. We have two different representatives from two different municipalities also here with us, one from Spain and one from the Netherlands. So it would also be interesting to hear your perspectives on whether you think, how's the current urban water systems in your municipality managed? What are the challenges that you're facing? And how do you think the latest technological innovations can help you with this? Maybe we can start with Wiebke and then move to Daphne and Manuel after that.
Julian, before the presentation of Wiebke, I will show you the Crumbly Park video demo, because I think it's better to understand what she's going to tell us. So I will share with you again the screen, and there we go.
Great, thank you.
In het Crumbly Park hadden we de kans om een uitvoeringsbudget van de Europese Unie in een wijk toe te passen om die wijk extra klimaatbestendig te maken. We hebben hiervoor gekozen omdat er een renovatie van het park al gepland was. En we zagen dat als een mooie kans om dat lopende project extra klimaatbestendig te maken.
De waterbuffer is eigenlijk een circulaire oplossing voor regenwater in de stad. Op die manier zorgen we eigenlijk dat het regenwater dat in die natte maanden valt niet tot overlast leidt. Maar benutten we dat als kans om dat water vast te houden en in te zetten in die droge periodes dat we eigenlijk water tekort komen.
Net zoals alle gemeenten in Nederland is de gemeente Den Haag bezig met klimaatadaptatie. We weten al met z'n allen dat wij last hebben van hevige zomers, van meer droogte en deels van hele heftige regenbuien die schade en overlast kunnen veroorzaken. Dus we gaan vooraf nu ons aanpassen aan die weersituaties, zodat we de stad leefbaar kunnen houden, nu en in de toekomst.
Door dit soort projecten samen met bewoners te doen, maak je meters. Het doel was een vlieguur-effect te krijgen, dus dat bewoners ook wat trots op hun woning gaan worden. Dat de hele wijk in zijn totaliteit verbetert. Door heel enthousiast met z'n allen aan zo'n park te werken, dat het park eigenlijk zo'n waterbuffer ook als cadeautje gekregen heeft. Van hier gebeurt wat, hier is iets bijzonders en daar is die waterbuffer heel goed op zijn plek.
De waterbuffer en Bluebloqs zijn eigenlijk uitermate geschikt om in iedere setting te passen. Dus het leuke is, wat wij doen bij Field Factors, is dat we vanuit de essentie van ons Bluebloqs biofilter heel veel ruimte hebben om mee te gaan ontwerpen, om echt een systeem te gaan ontwikkelen wat past bij de behoeften en de ruimte die jij hebt op jouw locatie.
Ik ben heel trots op dat we dit voor elkaar hebben gekregen. Dat het er ligt en dat we dus daardoor ook hopelijk een oplossing hebben waar wij als stad van kunnen leren en ook daarbuiten. Dat ook echt een toegevoegde waarde is voor de mensen.
Adam, I think you have to unmute. Yeah, it's okay.
Yeah.
All right. So this is the Crumbly demo. We haven't seen that one yet, so thanks for jumping in. And maybe also before we continue, just to I want to open up the discussion as well to the audience. So please feel free to shoot some questions, and I'll try to slip them in to the right people. And also for the panelists, feel free to jump in whenever you feel like you have something to add to something that one of the panelists is saying or to one of the questions. But then, so after this, we can hear from Wiebke to hear more about the challenges that the municipality of The Hague is facing. Yeah, so over to you, Wiebke.
Yes, thank you, Julian. So we are actually trying to make our city more climate responsive, and then we think of water management, but also extreme precipitations, but also heat and drought. And we have an approach in which we combine those measures, and that's why the Bluebloqs system is especially interesting because it is a solution for all the 3 challenges that we are facing. So we actually widen it from water management also to create heat responsive urban places. For that issue, we need to have water available within the city, local water, to irrigate plants, so to improve the evapotranspiration. So there we see the big advantage. And I think the big challenges, of course, are to get insight in the vulnerable places within the city. This is what we are working on right now. So we have so-called stress tests. That's maps for the whole city to show where the vulnerable places would be in case of heavy rainfalls. And we're going to figure out how to solve those measures. But I think the Bluebloqs system, and also if I think back on the process that we had, it was a matter of having the right time and the right people in the right moment. Since you need a matter of urgency in a specific location and project, you need knowledge and finance. So that were the most important aspects that supported the implementation of the system in conflict.
Thank you, Wiebke. And so Daphne and Manuel, if you hear this from Wiebke, do you have similar challenges in Spain, or what's your situation?
I don't know regarding the city of Madrid. Maybe Manuel can speak more about the problems of the municipality. But we have similar, I agree with Marian and Vicky about the similar challenges and problems we have in Spain. One is the legislation. We have a reuse and reclamation legislation, but it's focused for the reclamation of wastewater treatment plants, mainly for irrigation or industry, but not for the reuse of rainwater. That has different challenges and different problems. And maybe we need to try to move a legislation, I don't know if in Europe, maybe in Spain, in order to proper use rainwater, because I think it's one of the opportunities we have for climate change and for the problems we are going to have more with water scarcity in Europe. We have many areas in the south of Europe, for example, in Spain, with real problems that could be solved with Bluebloqs or other systems like Bluebloqs for reuse of rainwater. That is an opportunity also for smart cities, for space in cities, for the irrigation of parks and different areas that are consuming a lot of water. In Spain, for example, potable water, that could be, we can use this kind of water to solve this problem. The main challenges I think are the same: to properly manage a storm or heavy rainwater episodes, and also to store water, maybe more in Spain, that we have a severe dryness during summer. We are more or less 2 or 3 months without water, and to store water for these moments is quite difficult. We need to get more than tanks to use underground or storage places, or in order to have enough water for summer. This is I think one of the challenges of Bluebloqs system, maybe also for big cities like Madrid that needs a lot of water during summer. But I think it's a really good system that could solve a lot of problems that we will have now we have and we will have in the future.
Thank you, Daphne. That's very insightful. And I'd be curious to hear if of course, Manuel agrees from the municipality of Madrid. I'm sure there's a lot of heat stress in Madrid, especially compared to the Netherlands. So do you think, Manuel, that is legislation the main barrier? And maybe it'd also be interesting to hear how you can overcome, or are there plans to overcome these legislation barriers?
Julian, let me introduce Manuel, because we have this mistake at the beginning. Manuel de Pasos is the person from the public space and infrastructure of the municipality of Madrid, who has been engaged with the project since the beginning, and thanks to him, we are now able to install the Bluebloqs demo at the Kaleido Park. So we thank Manuel for all of his help. And now, Manuel, nos pregunta Julian acerca del enfoque del ayuntamiento a este tipo de tecnologías, así como qué hace falta para implementarlas.
Bien, bueno, en primer lugar pido disculpas por tengo un ancho de banda bastante deficiente y a veces se me corta y no puedo escuchar perfectamente esto, con lo cual disculpas y por mi inglés deficiente.
Yes, well, I'm sorry because I am having troubles with my internet connection, and I didn't hear you at the beginning, and also because of my English. But
no problem. It's very, very impressive that so Manuel can overcome the legislatory barriers apparently to implement systems like Bluebloqs by himself. So that's already very great and exciting to have him. Yeah, so it'd be interesting to hear from Manuel about the main barriers in Madrid with regards to implementing systems like Bluebloqs.
Sí, Manuel, entonces, ¿cuáles serían las barreras y el enfoque del ayuntamiento a este tipo de tecnologías? ¿Qué es lo que...
Vale.
No se te escucha. No se escucha, Manuel. Manuel, no se escucha. Perdimos el audio.
Yeah, we just heard Vale and then it disappeared.
Yes.
But maybe we can move to another question quickly before, just while we wait for Manuel.
Well, what he said at the beginning is that the city council has implemented the SOTs for a long time ago, and they are now reducing the paving surface of impervious occupations to those surfaces to where it's strictly necessary. Then, addition, they are establishing the guidelines of control erosion and water pollution in areas under construction and works on public driveway. And also that they are currently adopting the such techniques for all green areas, new green areas at the municipality, and they are also working on improving their efficiency and the design and implementation.
Okay, thanks. So while we just wait for Manuel to get back with us, maybe we can move to the Dutch context, and you know we've seen a couple of videos with the first pilots and systems that have been implemented. So I can imagine the next step would be how we can start scaling technologies like this, and maybe Marianne can help us with how that looks like the coming years.
What we have seen so far is that we have done a few pilot projects, so from the field labs to the real situation, but all projects were with. So it's not yet in the standard system, the standard operation of municipalities. So when an organization has a special subsidy, either from the European Commission or Climate Kick or whatever, then it's able to implement such an innovation. If not, then the municipality often still opt for the standard options. So what we always discuss with our local governments is to include in their procurement documents also the this specific needs for sustainable solutions and these kind of things, because otherwise it will never pass through these procedures.
Great. So maybe is that something you see on your side? Is that changing the procurement process, Wiebke and Manuel?
Yes, I think that I think we are really in an ongoing process in terms of procurement processes, but also in terms of setting criteria for urban development, also for urban renovations on our own ground. This is a rather slow process, I need to say, unfortunately. So we are now making our own criteria, which we give to developers, for example, that explain what aims they need to reach in order to make a new development climate responsive. So how much water they need to store locally, how much green is needed, and stuff like that. And I think those are the first steps to provide a guiding. Then it's of course up to the developer to fill in a specific solution and a measure. But still, I think that I completely agree with Marian's opinion. We really need at this moment we need additional finance to be able to install a system like this. So we were really lucky that we had the ability to use a Interreg project, Nature Smart Cities finance, which is 400,000 euro. So we would never have been able to implement this system into the conflict line without this financial extra. And otherwise we do the stuff as we do it usual. And of course, also there we try to make small improvements in order to make developments more climate responsive. But such a iconic project that we realized in the conflict park, where we are really very proud of, that was only possible through extra finances.
Right, thank you.
Excuse me, one other point I want to mention. But because what we also see is that when we started with this project, kind of this snowball effect, once we started and we got more publicity about it, we also saw that it also generates energy and interest of other parties to join. So it's not only something that forces money and energy, but also in return we got a lot of interest and collaboration back. So also the aspect that Daphne mentioned before, we collaborate closely together with the water board Delftland, and also the drinking and nature conservation body Dunea, who are responsible for providing the city with drinking water. We closely collaborate with them because they, on the long term, also are responsible for providing drinking water to the city, and also they see this as a possible solution, and they collaborate with us in the monitoring and maintenance to develop own knowledge in order to scale it up. It's also this upscaling idea is something that I see for this kind of other parties and not that much for the municipality itself.
Right, it seems like that's sort of like a positive feedback loop. Then you start with one project and then everyone gets excited.
And even more, sorry, one more thing, even a local housing cooperation that has his housing directly around the conflict park became involved in the project, and we were able to get 1,000 square meters from their roof surface. Also, how to say that in English? We linked it to the urban water buffer system so that it's not going into the sewer system, but that it's also infiltrated and cleaned and infiltrated in the ground. So it's even more effective. And the nice thing also is that if we tell the story to the inhabitants that live around the conflict park, they really get excited about it and they are proud about it. So this is also nice to see, and it's very it's very tangible for them to say, okay, in one season we have too much water, so we store it under your park, just right in front of your house, and then we use it in the summertime in order to give water to the plants, so they cool your neighborhood much more. It's nice and green, and you can make use of it. So yeah, they know, they understand the simple story, and they even some people even ask for having extra rain. How are those things called? Regentonnen.
What, a barrel? A barrel? A rainwater, like a barrel.
Barrel.
Is that the word?
Yeah? I don't know the English word, I'm sorry.
But
they, in their own gardens or in their own balconies, they started off how they can use the same big system in small for their own private balcony or garden. That was really nice to hear.
Yeah, thanks. I'd love to continue more, and I think it's great to hear this beautiful success story. But I'm also looking at the time, and we still have a very strong finish from Kieran himself. Although it seems like we're just diving into the interesting stuff here. I have to leave it at a cliffhanger from here on, because then Kieran can still give his short presentation. So thanks a lot for your inputs, panelists. It's been very brief, I'm aware, but yeah, we have to keep an eye on the time. But maybe just one last question from Manuel. It would be great to hear a little bit your comparison with regards to what Wiebke has been saying. Would you be able to share a little bit, just a little bit about the situation in Madrid? Do you have similar experience to Wiebke? Because we're hearing a lot of inspirational things happening here in The Hague. But I think the audience would also be very interested in hearing what it's like in Madrid.
Yeah, well, I have Manuel on the phone because we are getting technical trouble. So, Manuel, ¿nos podrías dar tu enfoque de cuál es el enfoque del ayuntamiento para poder implementar este tipo de tecnologías?
Bien. Vamos a ver, creo que es importante desarrollar la normativa existente en cuanto a la calidad del agua, con objeto de analizar los resultados y poder llegar en un futuro cercano a aprovechar este recurso para recargar acuíferos, uso en fuentes ornamentales, riego, etc.
Okay, it is necessary to develop existing regulations regarding water quality and to establish adequate and achievable parameters to take advantage of this resource to recharge aquifers, ornamental fountains, irrigation, etc.
También queremos dar un paso hacia adelante y empezar a proyectar áreas de bioretención para la gestión de las aguas de las calzadas, mediante su integración en el diseño de las vías públicas, que es un paso que aún en Madrid no se ha dado.
Also, bioretention areas will be implemented for the water treatment of the road, integrating them into the design of the public road.
Y es importante y esencial la colaboración público y privada, así como la intervención del ámbito científico. Y aprovecho para agradecer a mis compañeros, a Soledad y a Sofía, a Espacio Caleido como promotor de las obras y el estudio de arquitectura Fenwich y Ribarren, porque sin su colaboración no hubiera sido posible hacer esta demo que estamos realizando en Madrid.
Yes. Also, public-private collaboration is essential, always as the intervention of the scientific field. And he thanks for the cooperation of their teammates, Sofia and Soledad, but also to the owners of the Caleido Park and to the Fenwick and Environment architecture firm that has made possible the implementation of the demo in Madrid. Okay, thank you very much. Gracias, Manuel.
Thank you.
Thanks a lot, Manuel. Also great to hear from your side, and congrats on your achievements with implementing at Kaleidos. I'm aware we have very little time now, but maybe we can just jump straight to Kieran for the slot.
Yeah, thank you.
All right. Yeah, I feel sorry that I had to end this good panel discussion. I think some very relevant insights from the people working on this in the field, but also from the other end that we are as technology providers, as field factors. But in my role as the project coordinator from the Bluebloqs project, I have the honor of reflecting on the results that we achieved. And I wanted to start with the original idea that we started off with in terms of what we aim to achieve with the Bluebloqs project on the long term. And that is, as Carina already introduced, is that we believe it's time to make a transition from the centralized linear water system by creating more decentralized circular water systems in order to support the water managers in the city to not only prevent sewer overflows and to reduce the sewer replacement cost, but at the same time make that water available for reuse in the dry periods. So I think we've heard all about that, and the ambition that we actually had is a long-term one by 2030. We set out, like, wouldn't it be nice if we can actually have this decentralized grid, like the smart grid for energy, but also a decentralized grid of circular water systems that can help to communicate and to provide a real new source of fresh water for the urban areas. And of course, we know that's very ambitious and that's very much on the long run. But it's always good to sort of have in mind, what the future could look like. While at the same time, we have really been working much more on the practical side of things. And therefore, I want to take time here now to really say a word of thanks to all the partners that helped to make the great progress in the past 2 years. Of course, with Aquafin, UPM, and TU Delft, but also with the implementing partners, the municipalities of Madrid, of The Hague. It's really great to have Manuel Wiebke here, but also from the gemeente Leuven, eCatalyst. So I think with this team, we managed to achieve some really great results, and it's too short of time to share all of them with you, but I will sort of give it a try and see if I can make a brief summary of the work that was done and the impact we have created. In terms of the demos, much has been discussed on this, but I do want to highlight it is great that within 2 years' time, we managed to have all these different demos implemented throughout the European Union, in the Netherlands, in Belgium, and in Spain. But it's not just nice to have them implemented, it also helped to really make some major improvements on the technology. So through the demos and the testing we did, Joshua, with the amazing work that he has performed on this end, we really have been able to improve the treatment efficiency of the Bluebloqs solution to make sure that we are more consistent, but also be able to treat different types of water, make it available for different types of reuse. So we have been able to make some really nice progress on that. Also the design optimizations that Joshua has mentioned, the changes to the aerator, to distribution systems, they all help to improve the treatment efficiency. But at the same time, as you saw, all the different demos, the basis is the same, but there's continuous room for modifying it and making customizations to make sure it fits nicely in the urban area. And I think it's really nice that through this, the biofilter is not only a functional addition to the water system, but it also gives back something to the spatial environment and makes the area a nicer place to stay. But what came forward in the panel discussion, I think, and is one of the major outcomes also of implementing these demos, is the stakeholder engagement that it generated. I think it's nicely mentioned by Wiebke, sort of the snowball effect. As soon as you start showcasing what is possible, it's way easier for different stakeholders to get on board, to maybe become part of the innovation, to do the research, to see what else is possible, but also to give feedback on what can still be improved. So through these demos and showcasing the potential, but particularly the interaction that took place in various webinars and before the COVID situation in 2019 in some face-to-face meetings and guided tours has really helped to, build momentum and, to make progress on this. And the last thing is what Joshua mentioned, the importance of developing these operational procedures. It's not just something that just implementing these systems is not enough. It's all about making sure that they keep functioning in the way they are intended to. And for that, you really need to provide the right guidance to the operators in the public field. So I think that is something that we all achieved through the demos that were implemented. But of course, that's not all that happened. The demos were a major part of our project. But at the same time, we have been working on the business development side of things, doing surveys with potential clients, exploring the different product applications, developing a product service line to really be able to, as Marjan said, specify the impact Bluebloqs can have for a certain application and to explore which partners are able to invest in it, who will generate a return on investment on it. So lots of work in that regard. At the same time, we've been developing a configuration tool that even turned into a really pragmatic tool built into the Sirio platform, which is the go-to water design platform in Flanders. So that's very important to really make these options available to those people designing the water systems in Flanders, that they have a quick access and easy access to calculate what the impact could be. And also the capacity building, because it's not just a matter of implementing these solutions and proving technology works, but it's also about preparing the market for the uptake of, this rather new intervention in public space. So that's also about creating the knowledge in the operators, creating knowledge within the municipalities and the new procurement guidelines, as Wiebke said, to really make it possible to take up these innovations as a new, business as usual approach. That's also about changing institutions, legislations in Flanders, in Madrid. Birgit mentioned it. The ASR technology has a major potential to really, deal with many of the problems in the tight urban space and the water shortage in Flanders. But there is some limitations in regard to this, what is possible. So with that, we have taken a first step in communicating the knowledge from the way it is applied in the Netherlands, bringing them to Flanders, and then working all together to really make some institutional improvements. I won't go into detail on all of them, but I really do encourage you to, reach out to your local partner in Spain, in the Netherlands, or in Belgium, if you want to know more about this and really get into all these detailed results on these other components that were not elaborated on today. And with that, I have a few more things I would like to share with you. First of all, I think Karina started nicely by putting on the roadmap so far, where we came from. But one of the major results from the Climate Cake project and all the work that has been done by the entire consortium is that from the different IDEs, pilots, and replications that we had so far, we already have various new projects lined up for 2021. Not only in the Netherlands, also in Spain, in Valladolid. So I think the momentum that we have generated, we really see the uptake of these solutions, the interest from the market, that there is a real urgency to make a change and to make these next steps in order to prepare our cities and our urban environment for the climate change that is ahead of us, or that we already, not even ahead of us, but that is already hampering our cities as we speak. So that is one of the major outcomes, by showcasing the potential of the solutions, by getting in contact with the stakeholders, by developing the different operational protocols, by developing the product service line. We really were able to engage with new partners to keep this momentum going and to make this transition towards the large-scale uptake of circular water systems. And with that, it all sounds amazing, like, wow, what a great result. But of course, there are some lessons you learn over the course of a project. And with those 5, I really would like to send you home and briefly elaborate on all of those. And the first one, I think it's sort of the bottom line of part of the discussion in the panel, but
the technological innovation in the end is nearly always faster than institutional change. So it's really easy to define a problem, think about technical solutions to overcome these problems, to make these changes, to make these technological improvements. But if you don't have the ability to implement it because your business case is not right, or because legislation is falling behind, or because the implementing partners still have to prepare their procurement rules, you won't generate the momentum that you're after. So it's really good to be aware that technological innovation just moves rapidly, but at the same time, we continuously need to keep working on these institutional changes to make sure that all the, market conditions are set for the uptake of more sustainable solutions, not just for Bluebloqs as a circular water systems, but in general. If we want to create a systemic change, it's not just technology, but it's also about making these institutions ready for the uptake of these new innovations. The second conclusion, looking back at what we did throughout the project, is that the proof of concept requires tons of data on the system performance. We had the luxury of having these implemented demos, generating the data on system performance, being able to monitor them intensively. Unfortunately, we had a bit of a delay in the implementation of some of the demos due to COVID. So there is still a lot more data to come, but that's the great thing. These systems are implemented. They will continue running for the next 20, 30 years, and hopefully even longer. So the data that we will generate with that will even further allow us to understand the potential of the systems, the limitations, the room for improvement, and really define how good it works for certain applications under different climatological circumstances. And providing that evidence is critical if you want to convince new clients or new partners to make this transition with you. So generating the data and keeping the monitoring, I think it was also one of the reflections from Joshua, is critical if you want to further stimulate the uptake. The third one, viable business cases around rainwater reuse are not straightforward. We already heard that for the implementation in Conflict, there were some additional funds available that made it even more attractive. But we really need to specify what is the added value, what are the revenue streams that we can generate. But it's not as straightforward because we're implementing a system that can prevent damages on the long run due to sewer overflows. But at the same time, we're providing water, which is a completely separated market so far in the Dutch setting, but also in Flanders and in Spain. So we're trying to link two worlds together and generate a business model out of it. So that means that the people who's actually paying for the implementation might not be the one who's directly benefiting from the implementation. And at the same time, the drinking water price is still at a very low rate, which makes it super super easy for partners to just keep using the drinking water because it's cheap, but that does not necessarily mean that is the better option. So by creating an alternative that is more sustainable, but in the end also financially more sustainable, is something that we really need to continue working on to bridge this gap. And with just two left to give you, this one might be a little bit off from all the other lessons learned because it's not so much a practical one, but it's much more a context one. The effect of cultural changes, cultural differences, is often underestimated. We have been working in 3 different countries, all within the European Union. And you would say, like, if we have this technology in the Netherlands, it's rather easily to just replicate that and do that same trick in a different country, but it's not that easy. The cultural differences, the sort of wide room for improvement or for innovation in the Netherlands, as was defined by some of our partners. Like in the Netherlands, there's lots of room within municipalities, but also in legislation to innovate, to build pilots, to implement them. While if you compare it to the situation in Flanders, there's a really high demand for proof of concept before you actually are able to implement the pilot. So there's a completely different approach to how do we deal with innovation. And these differences are often underestimated, but they play a critical role if you want to exchange the knowledge, exchange practices, and build innovations throughout different countries. So that is really something that we concluded as a consortium. It's good to be aware that these differences exist and think about your mitigation measures to overcome potential barriers in this. And with that, I come to my closing statement. And the most important lesson that we hope that we were able to tell you today is that we are actually able to turn rainwater into a sustainable source of freshwater supplies. Of course, you've heard a lot about all the different barriers, challenges, things that still can be improved. But also if you take a step back and reflect on the last 2 years, we managed to implement these systems in real life. At first, there was an ambition to install a demo site at the UPM facilities. But because of the momentum we generated, because of the proof of concept we already have, it actually turned into the implementation of a new system in one of the most iconic new developments in the Madrid area. So we are actually we are doing it now in real life at different locations throughout Europe. So I think we can already conclude that it is indeed possible to use rainwater as a sustainable new source to make sure that we keep enough fresh water available in our cities. And that is at the end what our goal is. It's not about really generating that transition to this decentralized grid. It's all about making sure that we maintain and build livable cities with enough fresh water and that we can last for many years to come. So with that, I really want to thank everyone for their participation in the project. Thank Adam and the team of UPM for hosting this event today. And of course, the floor is open to any questions. But with that, I would thank you for all of those that spent the extra 15 minutes to hear me out. And I look forward to engaging with you in a different setting soon.
Thank you, Kieran. I don't know if anyone has a final question for Kieran or for any of the of the team. No. Well, thank you all for your attention. We hope you could learn something new today and help us to dissipate the awareness on the importance of recovery the rates of water in our cities. Thank you very much and take care. Bye-bye.
Thank you all.
Bye-bye.
Bye.
Thank you. Bye-bye.
Thank you very much. Bye.